So mainly there are two types of transport layer protocols. First one is TCP, second one is UDP. These are the main protocols in any layers, application layers or transport layers or network layers. These are the main basic protocols in the computer communication network. First one is TCP and the second one is UDP. So IP is also internet protocol, but IP can be used for connectionless services. So TCP is a basic protocol which is used for connection oriented protocol. For example, our local area network, and UDP is called as connectionless protocol. So mainly it is used for wireless communication or connectionless network services, right? So next we have discussed what is simple protocol. So simple protocol in the sense in the black diagram also we have seen when sender is ready to transmit the data packet, first RREP request has to be sent to the receiver. RREP control protocol. So after that, whether receiver is ready or not, it will communicate back to the sender through reply RREP. So first one is request RREQ, next one is RREP reply protocol. So after that, sender will transmit the data packet. So once the receiver receives the data packet, again there will be one more control packet that is called as ACK, acknowledgement control protocol, will be sent from receiver to the sender post device. So then complete communication will be happen. So in case if any data packet is not able to deliver to the receiver, right, then using some flow control, error control and congestion control, so the communication path will detect why data packet has not delivered to the receiver, right? So these are the process of a simple protocol. So next one is that is simple protocol procedure. So next one is stop and wait protocol. Also in last class we have discussed. So what is stop and wait protocol? For example, there are let us say 10 number of data packets are ready to transmit from the sender, right? So depends on priority. So which data packet will come. So the priority will be giving based on the priority in the sequential order 1, 2, 3, 4 like that. For example, if any data packet is not able to deliver to the receiver, then that will be in queue, right? Then second next protocol will be transmitted. When all the protocols are successfully transmitted, then whichever the protocol were not able to deliver to the receiver, again that protocol will be transmitted successfully. So until all the protocols deliver to the receiver, that will be keep on transmitting the receiver. That is called as finite state machine, right? Finite state machine algorithm will be used in the transport layer for any data packet is not able to deliver to the receiver, right? Finite machine state also. So this is the algorithm in case if any data packet is not transmitted to the receiver, then the cycle will be repeated. So that is called as finite state machine. So there are so many advantages in the finite state machine in the transport layer protocol. So we have seen in the black diagram also. So that is called as finite state machine. So that is also very important protocol. So stop and wait protocol also we have studied in the transport layer protocol. So next is go back n protocol. So go back n protocol is also similar to finite state machine, but the procedure is different, little bit different compared to the finite state machine. So go back in protocol is also called as go back in automatic repeat request, right? So go back in protocol is also called as go back in automatic repeat request, right? Repeat request, as I told you, in case for any reason, for any technical reason, when any data packet is not able to deliver to the destination, means receiver. So again, the same original data packet will be available at the sender. So receiver will communicate to the sender that this number of data packet is not delivered. So again, sender will retransmit request to the receiver. So based on the re-request, again receiver will send a reply, right, repeat replay to the sender for transmitting the previous, whichever the data packet was not able to transmit to the receiver. Same data packet will be transmitted to the receiver, right? So that is called as repeat request. So go back in protocol is similar to, as I told you, so finite state machine only, but procedure is a little bit quite different compared to the finite state machine, right? So that is called as a repeat request. So until all the data packet will deliver to the receiver, the processor, request, replay, and acknowledgement will be keep on repeating, right? So that is called as go backend protocol, right? So go backend protocol is a data link layer protocol that uses a sliding window method for reliable and sequential delivery of data frames. So using sliding window in one class, let us discuss what is sliding window. So using sliding window method for reliable and sequential delivery of data frames, right? So reliable means, as we know that UDP is not more reliable. So how to make it reliable? So using some algorithms. So that is called as a sliding window method. So basically UDP protocol is a wireless communication protocol, right? So that is not more reliable compared to TCP protocol, because that is connectionless protocol. So there is no guarantee, there is no 100% guarantee for delivering the data packet to the receiver. But using some techniques, that is called as using sliding window method, right, we can make UDPs more reliable. And sequential delivery of data frame, for example, just now I have told you, if there are 10 data packets are ready to transmit from the sender to the receiver, then the priority of the sequential order will be assigned to each data packet. Then whichever the data packet will come first, that will be transmitted, right? In case if it is not able to deliver to the receiver, again same procedure will be repeated. When the same procedure will be repeated until all the data packets will deliver to the receiver, right? The previous data packet, whichever was not delivered to the receiver, will not be transmitted. Once all the data packets are transmitted successfully without loss, then whichever data packets were not able to transmitted, the data packets will be transmitted next. That is called as sequential delivery of data frames. Then it is a case of sliding window protocol having to send window size of n and receiving window size of 1. So one is receiving window size of 1. So this is also logical transmitted data. So if data is successfully transmitted to the receiver, right, then the window size is 1. In case for any reason, for example, flow control, error control, or congestion control, if data packet is not able to deliver to the receiver, right, then the window size is 0. So that is the meaning, right? So using window size, that is sliding window. Sliding window is nothing but an algorithm, right? An algorithm or network algorithm or protocol for making UDP as more reliable. So that is called as a sliding window. So then sliding window size of 1. So that is n number of sizes. But receiving window size of 1, that is the data packet is successfully delivered to the receiver. Then to improve the efficiency of transmission, to fill the pipe, I will tell you. So multiple packets must be in transition while the sender is waiting for acknowledgement. As I told you, so once the data packet is ready to send, so there are three processes. One is request, RREQ. Second one is reply from the receiver. Right. Then sender will transmit the data packet. It also depends on the status of the receiver. Right. Once the receiver is successfully receives the data packet, then it will send ACK, means acknowledgement control packet to the sender. So that is the complete process of communication. So that is the meaning to improve the efficiency of transmission. So multiple packets must be in transition. The transition means that will be in buffer waiting state for transmitting one by one. It depends on the priority and the sequential order for the data packets will be transmitted. So that is called as a efficiency of transmission, right? So the copy of the sent packet until all the acknowledgement arrives, right? For let us say if there are 10 packet is ready, right? So until all the 10 packets delivered to the receiver, the ACK control control packet will be keep on sending to the receiver one by one when all the data packets deliver to the receiver. So this is called as go back N protocol. In black diagram, let us see, right? So the key to go back and right before receiving the acknowledgement, the receiver can only buffer one packet, right? For example, packet 5 is transmitting the receiver. So if packet 5 is successfully delivered to the receiver, so immediately acknowledgement will be sent to the sender. In case after transmitted packet number 5 to the receiver, in case because of some technical issues, if it is not able to deliver to the receiver, so definitely error signal will be transmitted to the sender. Once the error signal is transmitted to the sender, then sender comes to know that so that data packet has lost. So again the original data packet 5 will be available in the sender always. Original data packet will be retransmitted, right? That is called as the receiver can only buffer one packet. So all the packets will be in buffer. So in case if any data packet is not able to transmit, original data packet from the sender will be retransmitted, right? Then copy of the sent packets until the acknowledgement arrives. Same thing. So until all the data packets delivered to the receiver, right? The copy of the packet, copy of the sent packet means original data packet will be always available in the sender. Several data packets and acknowledgement can be in the channel at the same time, right? In the same time, in the same channel and same time, at the same time, in the same communication path at the same time, ACK signal will be transmitted to the sender. So stating that successfully received the data packet from the sender. So the conclusion, the overall conclusion of the go back N protocol is in the go back N protocol, the acknowledgement number is cumulative and defines the sequence number of the next packet expected to arrive. Right. So the packet size, so the packet sequence number, as we know that is 32-bit address we have seen. Right. So sequentially 1, 2, 3, 4, 5, like that depends on the priority. The sequential number will be assigned to each data packet. So until all the data packets will deliver to the receiver. Right. Sender will be waiting for the acknowledgement. So that is the acknowledgement number is cumulative. Acknowledgement number is also depends on the sequential number one by one, defines the sequence number of the next packet expected to arrive. Right. So this is the black diagram of go back N protocol. Right. Here we can see that the basic structure of transport layer protocol we have seen between sender and receiver. So at the sender, application layer and transport layer will be there. So when as I told you, see here in this black diagram we can observe that so data packet, acknowledgement number and checksum. So checksum will be used for detecting error in case if any data packet is not ready to deliver, right? So here we can see that in the forward direction, that is request is sending to the receiver. Next reply is sending to the sender, means receiver is ready to receive the data packet, right? So ACK signal, in the ACK also ACK number and checksum will be there. That is also ACK number is also cumulative and sequential, depends on the number of the data packets, right? So at the receiver, same application layer and the transport layer will be there. Between sender and receiver, right? So which protocol will come? Network layer protocol will come between application layer and transport layer, right? So at the bottom, first standing means there are 10, let us say 10 packets that will be in the queue, right? First standing. So that is called as a priority. Which one will come, which data packet will come, it will get the first starting number, second next packet, second, third, fourth, and so on up to n number, right? Right, logical channels, zeros and ones. So whichever the protocol will be transmitted, so all the protocol original information will be converted into binary numbers, digital numbers, that is zeros and ones, through AIR protocol, right? So here SJSN timer depends on timer. So like that, depends on the sequential number and the priority. So all the data packets will be transmitted to the receiver. So this is the mechanism of the go back N protocol. Right, dear students, if you have any doubt in the go back N protocol, please you can ask me. And also stop and wait protocol is also very important. Right, stop and wait protocol and go back N protocol. So on these two topics, you can get one question, right, from go back N protocol or simple and wait protocol. So with black diagram, you can give the description for 5 marks or 6 marks questions. So sometimes you can get what is stop and wait and go back N protocol. So explain briefly for 8 marks or 10 marks also, you may get this question, right? Question on this topic. So please, if you have any doubt, you can ask me. Is selective repeat protocol, right? Dear students, once again I'm telling you, there are 4 control packets in any layer. First one is RREP, request protocol. Second one is request protocol from the receiver, RREQ. Third one is ACK signal, ACK control packet. So from the receiver to the sender when the data packet is successfully delivered to the data. So along with these control packet, one more protocol is there, RRER. RRER, that is repeat error control protocol. Repeat error control protocol. So these are the main control packet when any layer is ready to active in the wireless communication. So first one is request, second one is replay, third one is acknowledgement, fourth one is if any data packet is not able to deliver to the receiver, that is called as a data loss. So when data is not able to deliver to the receiver, then receiver will communicate RRER control packet to the sender. Means there are some error. Because of error, the original data packet was not ready to deliver to the receiver. So that is the meaning of RRER protocol. Then immediately when RRER protocol transmitted from the receiver, then sender will replay, right? So means again the same procedure for whichever the data packet was not ready to receiver. So same procedure will be repeated, right? That is called as a selective repeat protocol. Understood? Transport layer protocol is also called as a selective repeat protocol, right? Let us see what is the mechanism. So please understand there are 4 control packets, right, in any protocol layers will be occur. So first one is RREP, second one is RREQ, third one is ACK acknowledgement signal, fourth one is RRER, right, request error, right, RRER control packet. So these are the main different control packets, and functions of each control packet you should be knowing. Right, next one is selective repeat protocol. The go back N protocol simplifies the process at the receiver. The receiver keeps track of only one variable and there is no need to buffer out of order packets. They are simply discarded, right? So once any data packet is not able to deliver to the receiver, at the receiver there is no buffer operation, right? Buffer operation will be there only at the sender for transmitting the data packet. But in receiver, so there is no need to buffer out of order packet. In case if any packet is out of order or loss, right? Buffer is not required at the receiver because immediately it will send RRER, error repeat error protocol, to the sender. That's all. So that information will not be in the queue. So immediately that will be transmitted, informed to the sender. So that is the meaning. So the receiver keeps track of only one variable. That's only one packet it will be detected, not all at a time. And there is no need to buffer out of order packets. They are simply discarded. That's all. So once any data packet is not able to deliver to the receiver, only one time that error, so means that original data packet, whichever is sent from the sender was not able to deliver at the receiver. Related to that communication, only one time receiver will communicate to the inform to the sender. That's all. Again, it will not be repeated. Simply that message will be discarded. So that is the meaning, right? Next, this protocol is inefficient if the underlying network protocol, right? So losses a lot of packets, right? So this protocol, this selective repeat protocol is inefficient if there are n number of, for example, more number of data packets are not delivered to the receiver because of data protocol loss. So each time a single packet is lost or corrupted, the sender resends all outstanding packets, even though some of these packets may have been received safe and sound, but out of order. If any data packet is out of order, so that data packet also will be retransmitted from the sender. So that is the meaning. Then if the network layer is losing many packets because of congestion in the network, then the resending of all these outstanding packets makes the congestion worse and the even more packets are lost, right? So because of congestion control, even if there is a number of data packets will be lost, again the transport layer will be retransmitted. Right. So this has an avalanche effect that may result in total collision of the network. Right. So all this information about the go back N protocol. So go back N protocol is similar to the selective repeat protocol. So that's why selective repeat protocol is another protocol which is similar to the go back N protocol, right? So that is resends only selective packets. So those that are actually lost. Dear students, one thing I will tell you. So the sender, what is the function of sender in case five packets are not able to deliver to the receiver. Again, all five packets will be retransmitted to the receiver. Right, but selective repeat protocol, what does it do? Selective repeat protocol will select only the important protocol based on the content or information. Only that selective packets will be retransmitted. So that's why selective repeat protocol. But go back N protocol, what it does? Go back N protocol. So whichever the protocol will be lost, all the protocol will be retransmitted. But selective repeat protocol can select only the selective data packets for resends, for retransmitting. So that is the difference between go back N protocol and selective repeat protocol. So go back N protocol, all the packets again will be transmitted, but selective protocol, it select only selected protocol for transmission. Right, then this is the structure of this is the structure of the selective repeat control protocol. Because selective repeat protocol is also one type of protocol at the transport layer. right? So that's why sender and receiver, both application and the transport layer will be there. So again, packets. So packet contains sequence number and a checksum, and ACK protocol is also there, like logical this one. So here at the bottom we can send but not acknowledge. So for example, sender will transmit the data packet. So because of some issues, that data packet will not be delivered at the receiver, right? In that case, ACK signal will not be transmitted from receiver to the sender. Then which protocol will be communicated to the sender? That is RRER protocol. Sorry, control packet. So when receiver will send RRER control packet to the sender, it means retransmitting of the original data packet to the receiver. Retransmitting of the original data packet to the receiver. So that is the meaning. Then acknowledge out of order. Another color will specify that acknowledge out of order. Right. In case if any data packet is out of order and not able to deliver, then acknowledgement is also out of order if data packet is not delivered properly. Understood? So in first color, sent but not acknowledged means data packet is transmitted from the sender but not out of order. So in that case, acknowledgement will not be transmitted. So in place of acknowledgement, RRER control packet will be transmitted. Right. In the second case, acknowledge out of order. If any data packet is out of order, so acknowledgement ACK signal is also out of order. Again at the bottom, first outstanding, next send means this is send window. Right. Window N we have discussed in the previous slide. So window slide N. So depends on the order of the data packet, the sequential order of the data packet. For example, you first packet will come, so that is called as first priority. Packet 1, packet 2, packet 3, 5 up to N, that is called as send window slide, send window or sliding window of size N. Right. So here all these packets are in buffer at the sender. Then timer is also there. Timer also within specific time the protocol has to transmit to the receiver, and it should be successfully delivered to the receiver. That is so depends on expiry time of data packets we can calculate, right? Then at the receiver, packet received out of order. In case packet received out of order, so only one time the RRER protocol will be transmitted to the sender. That will not be available in the buffer. That message will be discarded. Right. But at the sender, in case if any data packet is out of order or lost, original data packet will be available at the sender. Then the sender will be retransmitted. But receiver will not do like that. So only one time it will inform to the sender. ACK signal or RRER signal. So this is selective repeat protocol. So selective repeat, only selected protocol will be retransmitted to the receiver. Now what is user datagram protocol? Dear students, if you have any doubt on the selective repeat protocol, you can ask me. Difference I will tell you. Go back in protocol will retransmit all the protocols which protocols were not able to deliver to the receiver. But selective repeat protocol can select only selective data packets for the retransmission. That's all. Now what is UDP protocol? Let us see. Right. So you, as we know that the basic definition or function of user datagram protocol is UDP is a connectionless and unreliable transport protocol. Right. So TCP and UDP are the transport layer protocol, but UDP is connectionless and unreliable transport protocol. It doesn't add anything to the services of IP except for providing process to process communication instead of host to host communication, right? So it doesn't add, means UDP can provide services of process to process communication to the UDP instead of host to host communication. right? So, but TCP will provide host-to-host communication, direct communication between sender and receiver. But UDP doesn't do like that. So UDP will provide. So only UDP will provide only the connectionless protocol for the host system. So, but TCP will provide host-to-host communication instead of process-to-process communication. So, UDP will provide process-to-process communication, but TCP will provide host-to-host communication. So, these are the main differences between UDP and TCP/IP protocol. So, these are the main differences between UDP and TCP protocol. UDP is very simple protocol using a minimum of overhead. Dear students, UDP is very simple protocol. How we can say that? One example I will give you. In any transportation, with high speed and low cost. With high speed and low cost, if anything is delivered to the customer, so we can say that that is efficient protocol, right? So meaning is understood that with high speed and low cost, if any product is delivered to the customer, so definitely that protocol is called as a efficient protocol. So UDP is also like that only. So with high speed and low cost, UDP will be able to transmitting the data packet, right? So that's why UDP is a very simple protocol using a minimum overhead. Right. If a process wants to send a small message and doesn't care much about reliability, it can use UDP, right? So that's why I told you UDP is very simple protocol. Right. Sending a small message using UDP takes much lesser interaction between sender and receiver compared to the TCP. So in TCP protocol, there are maximum of overhead will be there because that is connection oriented. So many errors will be, interference will be there. But in UDP protocol is wireless communication, means connectionless protocol. So there will be minimum of overhead in UDP protocol. So that's why I told you. So how can we say that efficient protocol with high speed and less cost? Less cost if any product is delivered to the customer, so we can say that efficient. Now let us see what is the UDP protocol structure. So UDP packets is also called as user datagrams, right? So what is user datagram? The basic definition, let us see. So whichever the data packets will be transmitted at the UDP protocols, at UDP protocol, that packets is called as a user datagrams. Understood? So UDP packets is called as a user datagrams, have a fixed size header of 8 bytes. Right. So the size of the header will be fixed, that is 8 bytes made of 4 fields. That one here we can see that each of 2 bytes, that is called as a 16 bits. Right. The first 2 fields define the source and destination port number as usual. So in packet, usually what are the contents will be there? Source address, destination address, original data, and checksum to detect error will be there. Right. So here the first 2 fields in the UDP protocol, the first 2 fields means 8 bytes will be reserved for source address and destination address port numbers, right? The third field defines the total length of the user datagram. The third field will define the total length of the user datagram, comma header and plus data, right? What is the original size of the data packet will be specify in the third field, right? The 16 bits can define a total length. The 16 bits of user datagram defines a total length of 0 to 65,535 bytes. Right. So the total 16 bits will be varying from the address from 0 to 65,535 to power 16. However, the total length needs to be lost because UDP user datagram stored in a IP datagram. Right. IP is also connectionless. So that's why the size is similar to IP 0 to 65,000 bytes. The last field can carry the optional checksum. I told you what are the content of each packet. So each packet contents are, first one is source address, second one is destination address. So third is what is the actual size of the data, means original information. So then the final field is checksum to detect error, right? So this is the user datagram packet format. So from 0 to 65,535 bytes. So first 8 bytes, that is header, packet header, then remaining is data. So first two fields reserved for source port address and destination port number. Then the total length of the data packet, original information or data packet. Then last field is checksum. So first one is user UDP user datagram, second one is header format. So this is the basic contents and structure of the UDP packets.